Hey everybody, this is Larry. This is day 15 of the 30-day Leetcode challenge. You could say we're almost halfway there, like a song by Bon Jovi. Uh, yeah, if you like, hit the like button, hit the subscribe button, hit whatever button you like. Leave a comment. Either way, let me know how you did today. All right, let's go. Week three, the first problem, week three. That's interesting. Product of array except self. Given an array nums of n integers where n is greater than one, return an array output such that output sub I is equal to the product of all the elements in nums except for num sub I. Okay. Uh, what the? It is guaranteed that the product of elements of all any prefix and suffix of the array fits in the 32-bit integer pre-solve it without division and in O of n. Follow up. Can you solve it with constant space complexity? The output array does not. Okay, that's kind of a little cheesy, but okay. All right. So I think the so let's say we did let's say if this was a sum of array except self, then this is where the prefix sum comes into play. Then you just do all the sum of all the numbers and then just subtract out the number that you're processing, right? The num sub I, as you will. Um, but because we want the product, so you could kind of do something similar, but there is a little bit of a caveat, right? I mean, and you could kind of reduce this problem, if you will, because if you're very familiar with the prefix sum method, then you could convert the product of an array to a prefix sum because note that a times b is equal to log a plus log b, right? So in that case, um, well, this is if you do something like for num in nums, convert to log num, right? Then that would kind of give you the answer. But what's the problem with that? Well, the problem is that log only operates on the domain greater than zero, greater than zero, right? And nums in this case, we would have to think about, well, negative case and the zero case, which they actually don't give it to you at example. So you would have to kind of contemplate it. You have to count, do stuff, and just handle all the edge cases, I suppose, right? But so solve it without division. Is there a way to do it without division? I mean, n O of n. Uh, hmm. Oh, everything fits in int, so that's okay. So I think there are a couple of things I would think about. One is just so now we're just handling the edge cases. I think that'll be sufficient. Um, so yeah, so I think the first thing I'll do is count the number of zeros, and we could afford to be a little bit verbose for a little bit. Oops. And then now we can also, so the other thing that we talked about is the negative numbers, right? How do we handle negative numbers? So the thing with zeros is that, I mean, we kind of get, I mean, hopefully viewers of the stream have done multiplication problems before. And if you have a zero in the array, then everything is going, or the answer is just going to be zero, kind of, because you have to kind of handle, well, you have to subtract the nums sub I case, right? So if you're skipping the zero, then you still want the product of the entire array, and so forth. And then the other case that we're handling is the negative numbers. And that is kind of easier to reason. It's just about parity thing. I mean, as you know, the product of two negative number is going to be a positive number and so forth. So then we just keep track of how many negative numbers there are, and then counting the current, and then kind of keep track with the negative. Yeah, and then now the default case is going to be positive numbers. Let me think a little bit about the without division part. So my original goal was going to be just take the product of everything and then divide. But Hmm. And I don't. Some of this is kind of a little bit weird because it feels a little bit artificial. Um, like I would be very unhappy if without division is because you're doing some like other funky operator that is like division but just without using division, if that makes sense, which happens from time to time as a request. So if that's the case, I'll be a little bit sad. Um, yeah, but I think it's a beginning. Yeah, that is a constraint, and we should solve it without division maybe. But let's kind of do it with division, and then and then we could kind of think about it first, so then we can have at least like a base to build on. Um, okay, cool. So then now we have the product, which is technically the yeah, the product of the entire array, and then now we can do it again for num and nums. Let's just have a answer array or result array. Okay, if so now we put it out. Okay, if num is equal to 0, then we could write this in a number of ways, and I'm trying to figure out which one makes the most sense. Um, well, uh, okay, let's just say current 0 is equal to zeros, uh, current negatives is equal to negatives. So, and then if number 0 is 0, then current zeros. I think this will allow us to kind of write the test case a little bit easier, or like the math at the end a little bit easier, because and then now if the logical statements, if current zeros is still greater than 0, then the answer is just going to be 0. If the current negatives, well, in this case, we want to mod 2 to count the parity of how many of them, because if there's even number among them, then it's going to be the positive answer. And then if there's an odd number of negatives, then it'll be the odd answer, right? So, yeah, and this assumes that obviously uh, there's zero zeros. Uh, yeah. Oh, maybe I could. This would be slightly cleaner to write. If negative, then and start append product over the current number. Else, we want the negative of that. And I think actually you could probably rewrite this as the inverse of this, and then take this out of the if statement, because we want this in both cases. And then now we can just return it. And we definitely want to test a lot of edge cases. So let's just play around some of it. But let's make sure this works for this one first. But add a 0. So this should be all 0 except for the one where we skip zeros. Okay. Did I mess that up? Oh. This. Oh, we're skipping this one. No, we're skipping 0. So, how do I? In fact, I actually did not think this through a little bit. Yeah, I guess that's okay. Current zeros is for number of zeros that are outside the current number, and then if num is not 0, then we do this. Otherwise, we just return the product. And this is a very special case where, because this can only happen for one case where there's only 1 0. So, where's that one up to? Oh, whoops. No, that's. Oh, I see. Because yeah, okay. We have to make sure that this is not 0 first, as well. Whew, a lot of edge cases, but I think there are a lot of edge cases, so I think I have to add a couple more. Let's just take this one and then have 2 zeros. And I think all the numbers or all the results should be 0, or the expected answer should be 0. That's okay, and we don't want it anything. That's great. And then now let's play around with negative numbers, but let's just play around with the one that has a 0 first. That should still take precedence. And then maybe this, and then add some random negative numbers. We also don't want the numbers to be too big so that it overflows, but should be okay, maybe. If not, then we'll see. Okay, so we do run into an issue. I think also in theory, looking back, maybe I could handle the zeros cases differently instead of linearly, but yeah, we definitely have. Oh, let me think about this. I took the negative of the product, but actually it should be negative of the absolute because the end result, like it should be independent of the end total product, if that makes sense. Um, so I guess I got lucky with the correct wrong answer. Um, so I'm just like taking a look. It's kind of hard. I wish they show different. Tell me anything. Okay, I guess it doesn't tell me. Yeah, and then just maybe some really easy, like one number based cases, which I guess n is greater than 1, so yeah. Oh, there's actually constraint checking, which is not always a thing. So, so I don't know if that's new or they wrote it for this problem or whatever, but good to know. Let's try some small one number things. Or two numbers, but one number's left. Okay, I mean this looks okay. Let's submit. Still, to be honest, not super confident about this 100%. Oh, because of stuff like this. Um, but oh, I should put this on top. Okay, I but yeah, and I guess I should have been because I needed an odd number. That's okay. I think to be honest, looking back, I thought that I could kind of uh, I thought I could box 0 as a special case, as a general thing, but or like a little bit of a deviant, not that much of a deviation. But it seems like that now, I looking back, I feel like I've got a big plus of just handling zeros separately. Like maybe I could, like looking back, maybe I could have a helper function of like handle zeros or something like that. Because there are only really two cases with zeros, right? One is if there's 1 0 in the entire array, then you do something you do well the product of everything on that 0, and then everything else is 0. And then we have 2 zeros, then everything's just going to be zeros, right? And that would simplify the problem a lot more. And I think I'm going to do that since I didn't get a right submit anyway. So handle zeros. Um, yeah, okay. Let's just so for nums, if let's put in the zeros counting here. Oops. But I think it bleeds into, because what you saw was kind of a little bit unfortunate because we end up having weird special cases that doesn't really make sense, but we're kind of hacking it together. And it makes it harder to debug, even though, I mean, I think we only need to make one more change here to get it correct. But in terms of getting the code clean, I think now that we see that the zero case is special enough that maybe we should have just put in another thing to handle it. Yeah, oops, and I wrote the same typo again. Okay, and then let's just return a tuple. Though maybe that's not a great idea. But in theory, maybe you return a named tuple. But at least for the purpose of for this, I'll just make it a regular tuple. Oh, and I might have said I should have done this in Java, but I forgot. Okay, maybe tomorrow. Okay, so if zeros is equal to, or if it's greater than 1, then we return just like an array times the length of, because it's always going to be zeros for all of it. And then let's make this a tuple. Just a really, just a status flag. Well, forget which way is more conventional, but if this is go to 1, we return, we handled it, and then it is, let's do the product as well here then. Else product, and then it is 0 times then of, okay, fine, let's just write it out. Answer is equal to nums, and then n sub, oh, I don't keep track of the index. 0 index is equal to none. 0 index is equal to index. This is a little bit verbose, but it allows us to separate our logic in a way that it allows us to debug things easier because it points to some part of the code, and then because these two parts of the code have very low dependency on each other, which is why we're refactoring this out. And the precondition, or the invariant here, is that when 0 is equal to 1, then 0 index will just have the one thing. Otherwise, just return false and none, and then we'll do the rest of it. Okay, so handled it. Okay, 0 results is equal to handle 0's nums. If handled, then return 0 results. Name is maybe slightly dubious, but, and then now we can handle all the other stuff without having to think about. I think we can do this now as a result. Let's move this up here. See how easy it makes the rest of our code, and they have no dependency, right, on each other. So okay, so let's kind of run the code again. There might be typos, so let's make sure that's okay. Okay, at least this new case is right, but this one seems to be wrong because I think I forgot to, because I think that was part of the if number is equal to 0 case, and that's why we have typos. Is this from now? Or from earlier? Can't tell. Oh no, yeah, okay. This is from earlier. Did I click on submit again by accident? I don't know, can't tell. But at least on a very cursory looks, it looks better now. So yeah, ooh, wait, it's this one, it's -5, -5. Oh, again, we forgot the absolute. I thought I multiplied by absolute here. Sorry, let me double check my code real quick. If we only count by absolute, then why is this? wrong. Hmm. Did I have this? But oh, I see. Because nums could be negative, so then okay, yeah. Because here we should only so the product should always be positive, but then the nums could be negative. So this will allow us to. In this case, now we don't need this because now then we just have an else. Because then now more code flow makes more sense. So let's submit this now. Maybe fingers crossed a little bit. Okay, so we did clean up the code and we did, yeah, we did get it submitted correctly. And the reason why that I was inclined to do this handle zeros thing is because there is very low dependency on this part of the code and this part of the code, right? And instead, it just when you put them together, like I did the first time, it increases computational what you call it? What's it called? Combinatorial, not computational, combinatorial explosion and stuff like this. So so yeah. How do we do it without division? Let me think about it for a second. I mean, there are ways to do it without. Yeah, and also that'll be now that we handle zeros, we don't have to worry about it. I think I was just thinking about zeros way too much in a weird way, or like how I was trying to fit it all into one custom. Uh, what's it called? One size fit all solution. But now that we took out the zero case, we can actually handle this better. So how can we do this without division, right? Well, now that we don't have to think about zeros and weirdness, we can actually separate the array. Let's say we have this array now. I don't know. I mean, I guess I could just take a random input. Or maybe not the one with the zeros. Let's say we have this array. We can actually just have essentially maybe a running pointer where well, okay, let's say we're on the current -6, then we just keep a product of the left and a product of the right, and then that's all you really need to do. And then you keep on, oh, well, I was gonna say you could divide it out to get the, divide it out to get the answer. But is that necessary? Because, well, okay, there are a couple of ways to kind of think about it, right? Because I think what I'm jumping ahead a little bit is the O of one space, because in this case, in order to move, so what I'm thinking about now is when I have to move from here to, to the right. Yeah, if I move this, right? Well, look, the left is easy shift because you just multiply by whatever number that you just add, the previous move. But on the right, you would have to divide by that number, which is, well, kills the point of this trick. I mean, of course, you could also pre-calculate all this and store it in an array, but that would be the O of n, at least in terms of space complexity. So how can we solve it in constant one space? Um, hmm. uh, Can we do it backwards? Yeah, I mean, I guess it really depends on the. Okay, I think this one is kind of crappy. Maybe, depending on what the solution is. Maybe I'll click on it. Because I think you can do something where, like, I don't know, one of these arrays is the answer array as a result. I remember reading this. I was like, why is this so like explicit? But I think if that's the case, then like, but I don't think that's. Look, when you're outputting it, if you output the constant, I don't know. I get annoyed about answers that requires these kind of like really hacky things. One is that it makes your code like one harder to read. So I would like if you do that in a code like in code that I'm reviewing, I would probably be like, look, use the extra O of n memory. You don't really need to do this unless you really know what you're doing and need the optimization. Like that just makes the code bad, right? Like you don't really make it that cleverer because you know because I think you could do some math on like you do a running count on like you store the answer right. So first just run the partial array. Um, yeah, I think that's how. I think that's one way to do it. Is okay. Just run the partial array. So like of the product. So like this is 1, 2, 6, 24. Was it 120? So basically just the prefix product, right? Dot dot dot. Uh, and then you do another one, maybe backwards. Uh, yeah. So then you would do another one so that you do a current count backwards from the end. So then this will be -5, and then now take that -5. Uh, well, first you do it with the empty array first, I suppose, to handle the for case, and you get this prefix. So then here your answer array would contain this prefix plus the empty array. Oops. And then now when you process the -5, um, your answer is already here, so then you update the entry on n minus, depending on what index you're using, n-1 or n-2, and then now you do like a reverse thing, and then your counter now is -20 when you process two numbers from the right, and then you multiply that by this prefix sum or prefix product, sorry, and then update it for the re-entry. So you could do it in over one extra space, but that use of the output array is kind of like, I don't know, a brain teaser that's, I feel like it's an anti-pattern at best and very useless in terms of like it's like almost negative correlation with the product. But yeah, okay, so this is a very detailed explanation of this problem, and it's not really that tricky of a problem in terms of understanding. There are a couple of techniques to kind of learn about. The only tricky part is breaking those cases down and going through them. And the without division part is actually kind of cute. Like you could use the two fingers algorithm, and it's kind of great. I'm not a fan of this quote unquote constant space complexity, where it's at best it's constant extra space. I mean, it's kind of nice optimization, but like I said, if you write code that does what I just mentioned, like I'll be like, you're trying too hard to be clever. Just do it the dumb way, where the dumb way is the code is way more readable. Um, that's what I would advocate. As an interviewer, this is an okay problem. It's a little bit too mathy, and not every I feel like not everyone is good because it's not even that the problem is hard in a math way. It's just that all the edge cases are mathy, if that makes sense. Like the zero cases, the negative cases, like yeah, maybe it's intuitive to people, but like maybe if they play around with math more, then it's more intuitive. Versus someone that who may be good engineer, but they never think about like multiplying numbers and what they mean by like, okay, like there's two zeros and that means this. If there 1 0, this means this, and so forth, right? It's a little bit weird of an edge case as a result. So for that, I don't think I dig this problem as an interviewer. I am not likely to use this. Um, as an interviewee, I mean, they're weird, tricky cases, but as long as you kind of talk through your thought process, I think this is okay. Like this is not too difficult of a problem. You just have to really be deliberate, be careful, and make sure you go for the edge cases, and your code will come from. And even I made a silly mistake, right, with not caring about this because I like I said coupled the code a little bit too tightly on the edge cases. As a comparative program, I mean, this is a relatively easy problem for comparative programming. Though I made mistakes, so I made mistakes. Mistakes were made. So I don't know. But in theory, that's definitely like problem that I should be confident about. And yeah, and I mean, make sure you understand the concept between prefix sums uh, and even though prefix sum is a very easy concept with like how it is usually structured, but understanding the whys and hows will allow you to extrapolate to problems like this one a little bit, and how to queries and how does querying work from between two indices, and how to get partial sums from the prefix sums and some or subarray sums and stuff like this. These are definitely things that would be helpful. Other possible solutions. I mean, we talked about two solutions here, or two or three solutions, depending on how you want to count, including one that I do not recommend. Though it's cute in a like, oh, that's cool, that's clever, kind of way. But definitely in a software engineering kind of way, I'll be like, yeah, you're trying to be too cute, and just do the basic thing that's readable, and you don't even get like it's not, don't do the complex thing just because it looks cool. Like if there's a huge performance gain and you need that performance gain, then maybe do it. But I would almost trade a little bit performance for readability and maintainability in edge cases. Yeah, I think that's all for this problem. Thanks for watching. This is not like I went a little bit deep on this one, though it's not a hard problem to understand. But I think I talked about some concepts about how to interview and how to go through this process in a very deliberate way. Let me know what you think. If you like it, hit the like button, hit the subscribe button, hit all the buttons. Thank you, and see you tomorrow. Bye bye.